At the outset, I'd like to thank Dr. Kadakwal, who has come all the way from Ministry. And he has a very tight schedule. He's here this morning and he's rushing off in the evening. And his intense care for the show, his personal commitment to the show. When we told him about this program, he was very, very impressed, and he said, "Sir, I would like to be part of this and make this probably a good technical success in our country." So I thank Kadakwalji Namaste, and I also thank Professor Vijay. Actually, unfortunately, Professor Sanasi Raj was supposed to have joined today, and due to the emergency in the midnight, he has requested his junior to come. And Professor Sanasi Raj is highlighted of this technology, and he is very happy. And we have already held a couple of sessions with him. And I welcome Dr. Vijay and also Dr.
My name is Arun. I'm from local Chennai. Very nice to meet you.
He is the Kotra, the local trade chief of Korean Trade Agency, and Mr. Kim, our colleague, and he is going to work with us, and he is the CEO of the company. I welcome him, and a mentor and a retired managing director of Saint-Gobain in Chennai. I have requested him, and he will conduct, and he will be the master of ceremony and conduct the entire program. Thank you, sir. Thanks for coming, and I request you to start.
It is very, very interesting and requirement in India, especially the southern coast, where we have a lot of erosion. So I think various technologies have been tried, and I've seen some of the details which YUJOO is presenting. So what they were doing earlier and how they have overcome, I think that is very, very interesting. I don't remember having seen it in Busan because Saint-Gobain had a factory in Busan. Though it's resort way, but Saint-Gobain had a factory in Busan, and I have not seen this particular working of, maybe it was done much later because I went in 2010. So I'm looking forward to a lot of discussions and a lot of interactions from all of us with YUJOO. But before that, I think we have with us Dr. Vijay, and thank you for coming from Delhi. I think he is the member secretary of the EAC. He is also a scientist at MOEF. So thank you, sir, for having me today, because this is a subject in which I think all of us are very much interested, and presence of you, especially from MOEF, will add a lot of weight, and you could take up this type of technology which is available in India, which is available now in India through HECS, whether it can be used for reducing the soil, the erosion, especially in the coastal erosion. I think Dr. Vijay, he primarily works on the numerical and experimental modeling of fluid structure interactions programs. His research interest lies in the application of innovative, cost-effective, thin porous structures as breakwaters in the field of coastal engineering, apart from coupled dynamics of risers, wave energy converters, and floating offshore wind turbines. He is currently working as assistant professor in the Department of Ocean Engineering at IIT Madras since 2021. Before joining, Dr. Vijay worked in the subsea flexible industry, ocean engineering technique, for about 5 years. He completed his MTech and PhD from IIT Madras and IIT Kharagpur. Presently, he is handling sponsored projects as principal investigator in the DST SERB Startup Research Grant, Naval Research Board, and Ministry of Earth Sciences. I think he also is guiding a lot of scholars, PhD scholars. So both of them are people who have knowledge of what is going wrong, and they will be able to really understand the technology when it is being presented to the Chief Minister, and will be here by about 12 o'clock. I now request Dr. Vijay to.
Professor Sanatha is supposed to be here due to some emergency he left, so I'm presenting on his behalf. And I also work on the similar area, so it'll be good. Okay, nice. Let's quickly get into the topic. So here we are about to discuss on the coastal protection structures and breakwaters. I like the technical seminar title, which is the care for your show, which is very interesting. Generally, the care word in the busy world we miss out, and something that not personal care, we care for the environment. So it is important and interesting. Yeah, the challenges along the Indian coast, so why it is important and why India should care about. As we know that on 3 sides we have covered by the seas, so it is important to talk about, and we have around 6,500 km plus coastline, and also a lot of rivers terminate there, so a lot of complex activities go around, and imbalances because of the sediments that come around from the river, and because of which the dynamics, a lot of changes that come in picture. And what are the problems that we face? So we have the major part with the east coast and west coast, and many of the rivers they go to the east coast, and we have the following problems: the siltation of the entrance channels. So a lot of ports are there, and they get so the navigation channels get always the water depth keeps changing because of the siltations, and there is a continual maintenance required, and closing of river mouth, and this closing of river mouth we happen to see it in Chennai, and we have this Guam as well, and problems concerning the aquaculture. So because of this kind of activities, what are the challenges that is happening around, and the siltation of the intake structures, and because of the global challenges that we have, and a lot of the intake structures are also available, and erosion along the east coast. So the average littoral depth, so because of the seasonal variations, and also because of the river mouth we have, so the littoral depth we happen to see that around 1 million meter cube per annum. So it is so huge, and because of the seasonal variation that we have, northeast monsoon and the southwest monsoon, and the aromas basically talk about the direction of the littoral drift, whether it is coming from the top to bottom or from the bottom to top, and the non-monsoon season. So the net drift, if we happen to see, it is primarily happening, and it is always on a higher side. Yeah. So on the various states, and what are the lengths of coastline that we have. So here we have a complete table wherein the length of coast affected by sea. If you happen to see the total length, if a significant portion of which is affected by the sea erosion, and there is a very interesting and challenging task ahead. Because of the human growth population. So primarily we are focused on the Tamil Nadu. If we happen to see, there is 27.95 kilometers of stretch. The length of coast has to be protected. So there's a lot of work to be done, and not just with the already existing technologies, but with some innovative technologies that will reduce the impact on the global activities. So typical damages near coast, when we generally put some kind of the stats, people are not much away, but with the actual scenario that is happening around. And we have cyclones every year. The Chennai also faces a lot of cyclone, and this is around the different parts of India, the Indian coast. Here you can see actually falling of temple by erosion in process. So why erosion is important? So that is of prime concern that we are here. And what are the different existing technologies, and what is the innovative technologies that we also look for, and how do we go forward. So primarily it all starts with some kind of a design, and some testing, and the real field implementation. So we are interested in understanding about the various design process, and also the innovative technologies, and how do we adapt to different site conditions. So these things are all site specific activities. Yeah. Next please. We have wave basins, wave plumes. So primarily for all these kind of model testing, we use the wave plumes. We have different capacities as well. I've worked with Professor Anasaj on different a couple of projects wherein it was interesting to see how it is done in the real field. So since I did not have experience of doing the experiments before, I was primarily with the numerical modeling, the coding guide. So I was into the real field implementation. So what goes on and how it is tested, and what are the different instrumentations that come in picture, and how what the industry or the real field people actually look for. So that is of some prime concern. So it is of different experience. So in the recent past, many of the time for countries like India, we don't have scarcity with the natural materials. So that is the reason why we happen to see breakwaters wherein the rubble mounds are there. So primarily we go on, we make some proper design, we do some preliminary work, and then we go for the real field implementation. So it is with the rubble mount breakwaters. But then for countries in the Middle East, for example, we don't happen to see the rocks, right? We will not have readily available materials. So how do we deal with it? So primarily we are focusing on how do we deal with uncertainty. So that is the focus, that is the area in which we try to expand. So how do we adapt to the growing demand situations? So for countries like the Middle East, wherein Kuwait or some regions, wherein we don't have much of the rock, and importing becomes a good, it becomes altogether a costly activity. So the business, when people are pitching in, so primarily focused on reduced investment, but the maximum benefit without any loss of the technicality and also the advantages that it is offering, right? So if I am starting a business, I want to invest less, but then I should be rewarded more. So with that as basis, things are moving forward in the recent times. So what we primarily do is, instead of going for the conventional breakwaters, how do we come up with, I'm happy to see a lot of models that have, I think they will be demonstrated or tested. Yeah, I think you can go to slide number 7. So what is the drawings coming out, and how it is all constructed, right? So depending on, so primary focus is on what is the water depth at that particular site. So depending on water depth, we come up with the solution that is required, right? Yeah, I think this is, yeah. Now we can go to full screen, I guess it should be okay. Hey, what enable, okay, fine. Yeah. So many of the places where the erosion is of prime concern, the seawalls have been put up, so generally massive and expensive, should be considered only where the adjoining shore is highly developed and the storm attack is very severe, and it is cross-shore sediment movement is dominant. So there are two ways in which the sediment transport basically happens: along the coast and also inward. Right, along-shore sediment transfer causes toe erosion. So can you go to the next? The toe erosion is of prime concern, which basically destabilizes the situation, and experience in the west coast viable in many pockets. So when we say pockets of the different regions, and experience in east coast not viable in many locations. So some pictures of interest wherein we have the seawall at the Puducherry, wherein you can actually happen to see a proper slope coming out, and some protection measure wherein to avoid any over a period of time, because all these things undergo, for example, all these things have a service life, right? So during the service, how does it work? So based on the experience, so some kind of a netted structure is also used. And there are two ways in which we generally do. One is the hard measures and the soft measures. Many of you might be aware of it. And this is one of the soft measures wherein the geotextile systems. The problem with this is that the locals, which many people don't know, if somebody punctures it, there is a chances of getting disturbed. So that is a prime reason. Still at many locations it is not adopted, but then these things are also coming up in combination with the existing methods. So the geotextile in combination with the some existing breakwater activities. So geotextile tubes at seawall. So yes, so there's some pictures of interest. So basically, this kind of many of us might have seen when we go outside. So wherein the apples, they have been put in some kind of a net. So the similar concept wherein all these kind of rocks have been well put up in some kind of a netted structure, and it has been so the primary focus is on keeping it intact. So you can see that over a period of time how the construction of a seawall, but then because of the erosion that happens, there is a failure that is likely to happen in the future. So how do we mitigate it? So that is our focus. So the failures primarily, as we said, the extreme wave actions. So one thing first we have to focus is on what is the impact of waves and what is the site conditions. and where we are putting it, and what is the possible solutions that is generally adopted in the past, and how are we planning to move forward. So progressive failure from locally weak point, and overtopping and the toe erosion, and post-direction techniques. So this is where the porosity starts switching in. So the primary aim of any coastal protection structure is to dissipate your waves, and also to give reduce the reflection, and also reduce the transmission in case of the place where it is intended to. So here are different pictures of interest. Yeah. So all these things, you can see that many of the places it is come in combination with the sea walls, right? So the breakwater, so as said earlier, depending on the water depth, whether it is a smaller water depth, or whether it is going to be increased, or it is going to be highly varying water depth. So the rubble mounds are chosen in this range, 0 to 8 meters, 8-on type breakwaters, wherein you deliberately construct some structures and put it on the site, and composite type, wherein these two things also pitch in. So impermeable structures obstruct the free passage of sediments. So that is a prime disadvantage of having this kind of a structure. The ideal breakwater is the one that allows for the free passage. So whenever I make any design, just like how you start a business. So in this particular case, when we have a coast, the coast should not be getting disturbed, but then it should not get eroded as well. So how do we do it? So that is the focus, and there should be a free passage of sediments, but then the energy dissipation or the impact of the energy at that localized area should come down. And the typical cross section of the rubble mound breakwater, you can see it here. So we have a top bed, and also how it is varying, and we do some ground preparation, and then we go on to construct different layers. You have the primary layer, and also the secondary layer, and the core layer. So depending on, and we follow for all these activities, whatever we do, it has to comply with these standards. So we have the Indian standards again. So all these things we take in consideration, and the slope 1:1.5. This is the rough value. And it is not necessary to be same on both sides. One side we have the seaside, one side we have the harbour side. So depending on the requirement, the slopes are also adjusted, and accordingly the materials are also chosen. So here you can see how it is being put, and here you can see the seaside. Generally the slope on the seaside, we have it of the 1:1.5, and again the similar way we try to have it on the D side. But again, as many of the times we try to discuss with the client to see what is required and whether it is workable. We do model testing it on our test facility and ensure it is fine. So as said earlier, to improve the energy dissipation characteristics, is there any other better way than the conventional rubble mound? So that is where the widely used concrete armor unit, wherein these things are precast in a site, and they brought it to the site, and also they have different combinations come in picture, and primarily they work on the base of interlocking mechanism. They primarily go on to lock it, so it has been precisely placed. Each module has been precisely placed, and so over a period of time, you can see how it has fared up. And this Acropod 2, I have worked with this Acropod, and we happen to see that there is no much difference with Acropod 1 and 2 primarily, except the projections that you happen to see. So primarily it is, I think for some kind of extension of their patented works. So the pipe supported breakwaters, this we recently also saw it in Vietnam, wherein they have a dedicated pipes over which the rubbles are put up. So I said the function of any breakwater is to dissipate the energy, to have reduce the reflection and transmission. So if you are able to construct a structure, if you are able to come up with some kind of a module that will do these kind of activities, wherein the energy dissipation is very high, reflection is less, and also the transmission is less. If it is able to do it, then it is a very good coastal protection structure. And these are some of the places where it has been come up. The idea or each one has their own advantages. As I said, the pipe breakwater, wherein it has been deliberately put up, and the good thing is that you don't need to have a lot of material for working with the pipe breakwaters, right? So you have a reduced area wherein you deliberately put the rocks between your pipes, wherein the combination of both the rocks and also the pipes are used. So lesser footprint, as said, so that's what we are talking about, and also the free passage of sediments. So recently we are also trying to work with the piles, wherein instead of having the rubbles, as you know that energy concentration is more on the sea surface. For example, you jump in a pool, much of the time you see the waves hitting on your interaction or your interface region only. So how do we dissipate the energy which is at the sea surface, but it is not required throughout the water depth? For example, 8 meters water depth if you have, you don't need to put so much volume of material. So you need to have the volume of material closer near the sea surface and a reduced material below. So how do we do it? So that is where the focus is going on. I'm pretty sure these models and also the discussion with you people will elevate us. So as the function of breakwaters, the transmission, reflection. The transmission is a prime, for example, if you are putting it primarily for the construction of your port and other things, the transmission of lesser than 0.5. So that is a rough number anyway, but we generally tend to keep it that if it is less than 0.5, it is meeting its needs. And reflection, as said, and also the energy dissipation has to be very high. So if you are able to, so all these things, much of the time, the theoretical front we put up, and we try to do some whether laboratory testing or numerical modeling, we try to combine them and to verify it basically, and also the run-up. So run-up, when we say it, primarily when the wave impinges on the structure, it moves on the structure, and how much it is trying to climb up. So that is what we call as the run-up. So and how do we what if the run-up is very high and it is higher than what is the projected area, so which means that it will overtop. So primarily all these things are all these things are linked, and dynamic pressures, and over a period of time how does it build up as well. And multi-purpose breakwaters, this is a very important place wherein we are trying to come up with the some kind of wave energy converters integrated to the breakwaters. So that is a project which we are also working on. Wherein instead of deliberate or instead of intentionally constructing some kind of a structure in the sea for supporting your wave energy converter, you mount it on your breakwater. So your breakwater, if you are constructing it, make it very good such that it will also support the wave energy converter. So that is the focus. And so it all starts with the foundation level. So the wave forces on the breakwater is also important, and how do we calculate it on the numerical front and also on the experimental side. So all these things, if you actually see, there is a boundary within which they all work on. So I'll be happy to explore more and more with this seminar. So pipe supported breakwater. So as said, the primary focus is on reducing the volume of material here. The pipe we have it, and much of the structure is just here. So and also we also have some kind of a porous structure, primarily aimed at increasing the energy dissipation. So primarily we are increasing the vorticity that is happening at the initial region or the interaction zone. And some of the combinations, always there exist a lot of varieties, and we can also propose something and to come out, and if it is going to work in different sea states, then I think it is good to go. So the curved front face structures exhibit reduce the reflection of waves. Arc plate was also found to be better than the horizontal plate. So this is also something which recently we are also trying to work with some kind of a funnel shaped structure, right? So wherein the wave energy converters also can be mounted. So all these things revolve around the return on investment. So if you happen to see as a client or what they want is, I invest this much money, how do I get it back, and how does it solve the purpose? So with these as basis, if we are able to think beyond, it will be very great. Okay, so the new concepts of pipe supported breakwater with berthing facility, as said. So along with your berthing facility, some kind of a structure. So for example, the OWC energy conversion, and also the heaving buoy. So that is the one that I'm presently working on. And it is very interesting. The problem with all these wave energy converters is the efficiency. So generally, if you happen to see hydrodynamic efficiency, you get it very high. But finally, at the end, we happen to get 15 to 20%. So it's reduced efficiency. So we are trying to push that one, but then there are other ways in which you can compensate. The amount of investment that you do. Having reduced amount of investment and also trying to maximize the energy capturing. Right? So that is the thought process. In this case, Star has put an OWC device mounted on pipes, so that is some studies they have been working on. Yeah. So I said here you can see a lot of Tuca structures. I saw a couple of experiments worked out here. So primarily focused on energy dissipation in this case. So we are trying to create the turbulence at that region, the interaction zone, wherein the energy dissipation happens very high, and it just solves your purpose. And we also measure what is the forces that come and the moment that comes at your pile board. And when it comes to the methodology, we generally don't get into the experiments at the very front. That is the way in which for any kind of project. So we first do a lot of numerical investigations. Once we zoom in on a couple of ideas wherein it is proving to be very promising, then we venture on to do the experiment. So experiment is a very costly business when the moment you touch it, starting from acquiring the facility and also the materials required and also the manpower to do the experiment. All these things are very costly. So before we get into this, we do the numerical modeling extensively. Then we go on to do the experimental only for a selected few. Some of the experiments that's done in our facility. So many of the times we also divide our facility to do two testings at a particular time itself. So that will help us understand for a given time how does one structure performs and the other structure also behaves. So on a simultaneous activity, I said much of the time we are focused on getting the reflection, the transmission, and also the forces that come on the structure. And if you are going to integrate it with some kind of an wave energy devices, so how are we going to measure it? Whether it is going to be the heaving buoy or kind of a trapped zone wherein the OWCs are some concepts. So overtopping, how we generally do it in our lab is primarily we have some kind of a collecting some kind of a small tray wherein for a given wave, how much amount of water is overtopping the structure and it is collected. So based on which we projected, okay, 1:40 scale or 1:30 scale, this much will be the volume of or this much amount of water will be overtopped and this will cause the damage. So that way we do on an experimental front. So some stages of experiments and how it is done, and we also have some kind of a staple type. So many of the concepts that you see here is primarily you might have come across in some places. So it is all trying to integrate it and work out. So moderate transmission, tranquility. So tranquility, so this is a word they use primarily for any breakwaters. So the primary function of your breakwater should be to create a tranquil zone. So shelter for marine habitats and exchange of water masses. Some places they deliberately add some kind of reef. So for example, if you see in the Lakshadweep Islands are close to that, so IIT Madras they have given the design and they have deployed a lot of artificial reefs. So primarily at aiming to increase the marine habitats. So exchange of water masses between the offshore and onshore regions. And this is one model that they have attempted before, and this is what we see in the Lakshadweep. If you have Google, I mean you can just put it. IIT Madras efforts on this Lakshadweep marine habitat. You can see a lot of the real field implementations as well. And the materials, so depending on the requirement, as said, we cannot give a direct solution. So first thing is we sit with the client to talk about what they actually want to do, and for a given site, what is the previous work. So always take lessons from the previous activities, and based on the previous activities and with the present technology, how do we get better? So that is in a nutshell, if you want to put it, this is the way in which things are progressing at IIT Madras. So some of the different items that come in picture that have been put up. And I said the structural configuration, the permeable rubble mound, the impermeable structure. The problem with these impermeable structures is that they do not help us in dissipating the energy. But then again, depending on type of the configuration, how you have it. So if you are having some kind of intricate shape, then of course it does its business. So geotextile tubes as well. So the challenges are the scar, the run-up, overtopping and inundation. And the selection strategy based on availability. So as I said earlier, based on availability, right? So preferred choice and functionality, what it has to do, and the proven design principles. So for all these things, so that is why we do the model testing as a primary. When you are going for the real field implementation, the model testing is of prime activity. So space constraints and the environment, so it should not impact the environment as well. And recently with TWPRS in Pune, they are also coming up with using the ash as a material for constructing their rubble. So not rubble, basically they are constructing some kind of structures with which, so it is some people don't want it, so we take it as an input and how do we make it forward. So that is also a thought process. Yeah. So the innovations in coastal structures, so I said the innovations in the sense it has to be a non-traditional approach, right? And the construction method, material, configuration, shape, concept or device that has a sound engineering basis. So whatever we do, some extensive work has to be done at a laboratory scale and also at the numerical strength before we put up in the real field. So improve current methods, low height, broad fisted structures, alternative structural forms, interlocking. So all these tetrapod, tripod, hexapod, all these things work in the concept of interlocking. It is like they help each other and also they stay intact and in place, just like your chain. So they are all interlocked to be there, right? So the same process. So interlocking and alternative materials. We said any other materials with which we can work out. And the geosynthetic, use of vegetation and other bioengineered approaches. So these are some of the ways in which we can bring the innovation into the coastal protection structures and how do we get better. So the problems in the near coast are dynamic and never end. So as long as the human population exists and also we focus on the protection, so it is always a dynamic, so we have to change with the changes that picture said, and how do we work out. And some recent or the publications that have been well documented in some of the books by our senior people, Professor Sundar and Sanazad, and they have been shown here for your reference. I also request everybody to step in at IIT Madras so that we can also showcase the state-of-the-art facilities, so that gives a good feel about what are things that go in and what are things that you want to do experiment. So we are also happy to assist you there. Thank you. We make some shoreline changes, for example, in the Tamil Nadu region. So that will also have an impact on the other part. So over a period of time, you happen to see that erosion happens at one particular region and also the accretion on the other. So, for example, if the Pulicat region is a focus that is on, for example, if there is a good water exchange, primarily we are talking about that because of, so first thing is we tend to see what are things, why it has come out. First thing is, first we address the question, why it has happened, and what is the way in which you can make it better. For example, having a clear entrance. For example, this could also be possibly because of a reduced exchange of water at that region, because of which whatever the minerals at that particular region might have continued to settle because of over a period of time, and also some kind of wastages that may be being there at that location for or some kind of an. It is like you have a body and how much the inflow should be there for outflow as well, right? For example, so I think it has to be worked out sitting with, understanding about the dynamics at that region and also studying about what has caused it and how do we bring it back in place. Right? I think a lot of effort has to be taken care. Yes.
Your presentation was wonderful. I really liked it. Very useful. I have got two questions. First question is that why can't we use the pyramid shape this thing for the sea erosion control? You have used different types of techno. Why pyramid cannot be used? Because pyramid is the basic structure. It has been generated thousands of years back. And then another thing is the concern about the green energy. There has been some research going on to generate electricity from the waves. Yes. So can we do some coastal safety for that generation of power from the ocean current, which is a useful thing, because there has been concern for the climate change impact. So is it possible, is it viable, economically viable to generate power through ocean current waves? Because we are facing every time during monsoon time.
So for example, if we take it in Israel, so in the port of Jaffa in Israel, so they have actually implemented the heaving buoy for the wave power extraction. So we are also thinking, so there are challenges involved. For example, our conditions are little Bay of Bengal. Basically, it's all little protected compared to what is the conditions at different parts of the world. So, but there are ways in which you can also focus the waves. So just like erosion happens because of the focus rays and deposition, accretion happens for multiple reasons, right? So we have to see to, for example, if you are concentrating on energy extraction, you need to have a very high weather. In the sense, you need to have a very little bit rougher side. So, for example, a heaving structure, right? It also it has to resonate with the waves. It has to get vibrated all the time. So we need to see what is the dominating wave period at that particular site, and how do we tune your structure such that it will be operable in all the seasons. So that is one part wherein we are trying to get some reasonable outcomes so that we can go for the, recently we filed a patent for one of our interesting concepts with my students. So that is a very nice, I hope it will work, but then we need to do a lot of TRS. So in India we have a nice levels that has been given.
But economic viability is also one of the biggest factors. Except it has got lots of limitations because economically it's viable.
Yeah, that's why I mentioned in the presentation also, for all these kind of structures, the devices, the efficiency is very low. See, for example, if I invest 100 rupees or 1 lakh rupees, when will I get it back? So that's a question. So as an investor, so that is a point that stops people from stepping in. So if I invest 1 lakh, how will I get it back? So when you develop a technology, that should be easy to adopt. First thing, the reduced investment should be there, and also it should yield me good. Right, so the efficiency should be maximized. See, this 20%, so slowly we can push it, and we can have a technology, for example, instead of having multiple conversions. For example, I give 100 rupees, so it should not change from hand to hand. So there should be a direct conversion wherein I will be able to extract the, convert the wave power to a usable power. So that is one way where we can be focused on. And also the other side is the reduced investment itself. So these are the two ways. And the very first question that you asked about the pyramid. So I think that's I think that we have to come out. I mean, in the sense, I mean, they are all, the purpose meant, for example, the pyramids are meant for a different purpose. Yeah. What we are talking here is a completely of different scenario. So I think all the different scenario which we can fit, I mean, we can have a clear understanding about.
Thank you. Thank you.
Yes, almost.
And since it was not economically viable,
right.
It is now running only RO plants, sir.
Yes, sir. So as a seawater intake, that's what you mean, right? So that's what, I mean, over the period, for example, the last 2 to 3 decades, say the technology, earlier the wind turbines, all these things we see from the land. Now they have moved to the offshore, correct? So we invest all these things, what are the effort we put is basically a dot. So over a period of time, people connected to take it to the next level. So in the sense, what I want to say is, all these things, a lot of effort has to be continuously being put up, and over a period of time, you see it in reality.
Thank you.
I am Suresh Babu, Executive Engineer. Yes, sir. Actually, we have an experimental model set up in our Institute of Hydraulics and Hydrology, Pundi. Okay, sir. I think you might have visited, or I request you to visit.
I have visited, yeah.
Sir, the thing is, we have an experimental model set up there, so that we can check the stability analysis as well as performance analysis of groins, RMS valves, like that. Okay. So I request that whenever you are doing the mathematical modeling, sir, you can approach us also for doing the experimental analysis and experimental model also.
Sure.
I request, sir, even any of the companies are like HECS, whenever they are coming up with a new proposal for instead of PTP, something they have come out with a new proposal, no, sir. For that also, for assessing the performance as well as the stability study, they can approach ISH Pundi. We are a state government organization. We are right from the 1950. We are serving the people. Around 25 acres of land with us. We have 2 excellent coastal model trails where we can study the littoral drift of even the north pattern as well as the southern pattern also we can check. So excellent land setup as well as infrastructure facilities are available with us. Please utilize us also. Thank you, sir. Thank you.
Member Secretary, Coastal Regulation Zone, and dealing all 13 coastal states of India as a member secretary. Now so many policy decisions is going on between ministries. And then first of all, thanks to Dr. Moses from the HECS, my good friend from Korea, YUJOO, and Dr. Kim, and our distinguished guests and different participants in different areas. I'm looking very good gathering here, and one of the thing is it is very interesting as a policy decision by the Government of India side. And first of all, thanks to Dr. Vijay given very good technical session and solved a lot of problems from my side. Whatever the what type of structure they are making, engineering side, and it will be very good. And I will tell you, this is I will give no any PPT presentation, just simply give to policy type of thing in the ministry is going on. And I will tell you in government system, because coastal erosion in the CRZ deal by CRZ notification. Earlier, you know, in CRZ notification in Government of India and applicable in 91. Then after that, another notification issued or superseded in 2011, and now in year 19 already issued CRZ notification 19. And one good thing is the CRZ notification for the perspective of development side. I cannot say environment side. Development side is slightly liberal than the 11. But my suggestion for the Tamil Nadu government as well as the HECS is very good consultant about the environment angle in the coastal areas, and lot of proposal is coming for the environment, CRZ clearance in the ministry. And my simple suggestion is, go above the regulatory authority from the Tamil Nadu government. Please try to complete your CZMP 19. It is very good for you and coastal community and fisher community, local people, those who are residing in different parts. And still CZMP 19 is not applicable in Tamil Nadu. And as per the CRZ notification, soil conservation method is very much permissible activity. I have visited so many times in Chennai after taking charge of this coastal regulation zone. I don't know, my personal feeling is this way. Chennai is my second house. I am belonging from Uttarakhand to Pithagarh, but Chennai regularly visiting. It is that way. And what about this CZMP? Again, I am repeating to CZMP 19 that a lot of court cases is going on in the different area of the coastal areas. And one is the major decision by the entity in South Zone. Coastal regulation zone should also include in the CZMP 19. My better advice, it is very good decision by the direction given by the South Zone entity, and people are doing. But still, again, I am suggesting to you people, those who are dealing this type of thing, CZMP 19, you have to follow further. And I am coming to that, especially this particular session is going on here for your source. And so many methods are for the taking care of the shoreline. One is the big one, is the major is the engineering part. IIT is the very expertise in this case, especially from different IITs. IIT Chennai is very expert, and I have seen so many reports from their side. And another thing is, this is the engineering aspect. Second thing is my submission is the biological aspect. You have to also take care, because the sea erosion is sometimes it's very high, sometimes the medium type, sometimes is the low erosion status. Everywhere we may not put up to this tetrapod everywhere. We have to take care in the sustainable word nowadays is using. We have to take care that type of the thing. How we can save our the sea erosion area of shoreline. Last time I visited whole this Chennai area. From Pondicherry we started with our expert committee members in different, this is my personal experience I am sharing with you. From there, Pondicherry we went to up to the northern part of Chennai. This is 2-3 port is coming in the northern part up to Pulicat Lake. I have seen so many, Dr. Ramesh already, Dr. Vijay already shown in different figures. I have seen personally so many areas, hotel, houses that going to submerge due to soil erosion. from Puducherry to up to northern of Chennai. Chennai port also we have visited. My better advice, it should be remediation measures. Not only you put everywhere tetrapod and that biological measure also thing. Simply, why I am saying you people have seen so many, because I am suggesting this experience from the different regions. I have seen so many tetrapod placed in that Kerala belt. If you go to, we come to the coastal region of Kerala up to the West Bengal. What people are doing, everywhere tetrapod, whatever the structure, that structure issue I will come later on. Structure either new technology of YUJOO, Korea also doing, and earlier also so many reports suggested by the IIT Chennai. Kerala, they are putting tetrapod here, somewhere in 1 kilometer stretch of Kerala. Then that is moving up to Chennai, and that tetrapod is going toward up to the West Bengal. This is not the complete solution, because we are putting tetrapod here, then soil erosion comes to this way. And again we are putting tetrapod here, soil erosion to come to this way. Better we have to take care also the biological measure, long term, not a single short solution, engineering aspect. Immediately it looks very better, but in futuristic aspect it is not good for the shoreline people. This is my suggestion, what I feel. As per the Government of India, Ministry Environment Forest, we have cleared so many projects. I will tell you regarding especially so many news is coming. Chennai is flooded. Chennai is flooded. Why? Because so many your Coombe River, Adiyar River, I personally feel their mouth is closed by the siltation. Ministry has already given so many proposals from the government of Tamil Nadu. We already cleared Coombe River project, one Adiyar project. If mouth of that river is open, because it's interchange of the sea as well as the river, both ways you are feeling so many such type of things like aging of that river, because the mouth is closed. Water is stagnated and a lot of smell is coming from that way. But if that part, mouth of the river part opens, then exchange of the biological, if you come to that way, marine biology come to the river biology go to marine, exchange of migratory fishes, whatever the different type of the fauna. One thing is that way. That should be very much take care. Second thing is the different type of the drainage type of project also cleared by the ministry, because whenever the proposal comes, we are giving to CRZ clearance. Please take care to that type of from the administrative or government perspective I am saying. And these are the basic thing is what I in my mind coming right now. And second, I am coming to now this YUJOO technology. What I have seen, in Indian scenario, we are putting tetrapod. But slightly, what I feel this Korean technology or Kota people are submitting right now, this is the, whatever the current is coming, and that current speed, this stop and water go inside of that tetrapod and come out. But our tetrapod, what I have seen, recently in Pondicherry or wherever, this is the simply breaking the speed. Here is the with breaking of the speed that is the coming. Maybe technical point of view, IIT people can see is it feasible or not feasible. But my personal feeling in first appearance it looked very good. But technical people that IIT people can give this way. And overall, as a ministry, Government of India, I personally support to this technology, YUJOO technology, what I have seen right now and earlier also I have learned from different platforms. This is my personal concern. If you have any question regarding related to me, very most welcome. I have no issue. I can very much friendly to give to answer and this one. This is whatever the answer I have given, this is my personal, not in take to the ministry perspective, because I am coming here as a personal invitation and not on behalf of ministry means I have taken, but I am not giving this any answer from the ministry perspective. Thank you very much, and this is my personal views about this one. Once again, congratulate to the HECS, especially Dr. Moses, Dr. Kim from the Kotra, YUJOO Co Ltd, and all dignitaries attended this one. Dr. Vijay also, and Eisenhower, he is representing. So many people, I forgot some names, no issue. But my personal regard to all of them. Thank you very much. Thank you.
வணக்கம். சென்னை கிளிட்ஸுக்கு அட்வான்ஸ் வாழ்த்துக்கள். இன்றைய நாளில் வந்து நாங்கள் ஒரு டெக்னிக்கல் செமினார் காலையில் வச்சுருந்தோம். அதாவது இந்த தேசத்திற்கு கடற்கரையில் உண்டாகிற பிரச்சனைகள், அதாவது கடலோர அரிப்புக்காக ஒரு டெக்னிக்கல் சொல்யூஷன். வெளிநாட்டிலிருந்து இந்த கொரியா கம்பெனி, ஹெச்இசிஎஸ் சென்னையை சார்ந்த எங்கள் கம்பெனியும், சென்னை சார்ந்த எங்களோட கம்பெனியும் ஆல் இந்தியா லெவலில் பண்ணிகிட்ருக்குறோம். நாங்களும் இந்த கொரியா கம்பெனி, அதாவது அவங்க வந்து யூஜூ அப்படின்னு ஒரு கொரியா கம்பெனியும் சேர்ந்து இந்த கடல் அரிப்புக்கு ஒரு நல்ல விமோசனம், ஒரு டெக்னிக்கல் சொல்யூஷன், ஒரு பர்மனன்ட் சொல்யூஷன் பண்ணுவதற்காக நாங்கள் இணைந்து சேர்ந்து வேலை செய்வதற்காக நாங்கள் ஒரு அக்ரிமெண்ட் போட்டு ஒரே 2 பேரும் முனைந்து இதை வந்து இந்தியன் கோஸ்ட், குஜராத்லேருந்து வெஸ்ட் பெங்கால் வரைக்கும் எல்லா கோஸ்ட் ஏரியாலையும் இந்த பாதிப்பை வந்து ஸ்டடி பண்ணி அதை அட்ரஸ் பண்ணுறதுக்காக இவங்களோட ஒரு அக்ரிமெண்ட் போட்டு MOU போட்டு சேர்ந்து பணி செய்வதற்காக இதனால் இணைந்து ஒரு டெக்னிக்கல் செமினாரை நடத்தினோம். இந்த டெக்னிக்கல் செமினாரில் என்னென்னு கேட்டிங்கன்னா, என்னென்ன பாதிப்புகள் இருக்குது, அது நம்ம நாட்டு சட்டம் என்ன சொல்லுது, பிரபலங்களுடைய எக்ஸ்பீரியன்ஸ் எல்லாத்தையும் இன்றைக்கி காலைல வைத்தார்கள். கொரியா நாட்டை சேர்ந்த இவங்க வந்து சங்கிக்கும் அவங்க வந்து என்ன பண்ணாங்க, ஒரு டெக்னிக்கல் ப்ரெசன்டேஷன் கொடுத்து பலவிதமான ஆலோசனைகள் என்னென்ன அவங்களுடைய எக்ஸ்பீரியன்ஸில் செஞ்சுருக்கிறார்களோ, அவங்க ஒரு ஏகப்பட்ட பேட்டன்ட் வச்சுருக்கிறாங்க. அந்த பேட்டன்ட்டெல்லாம் கம்பைன் பண்ணி நம்ம வந்து நம்ம நாட்டுக்கு இந்த கோஸ்டல் இரோஷன் ப்ராப்ளத்துக்காக சொல்யூஷன் கொடுப்பதற்காக நாங்களும் அவங்களும் சேர்ந்துருக்கிறோம். அவரை நான் உங்களை இன்ட்ரடியூஸ் பண்ணுறேன். யூ ப்ளீஸ் ஸ்பீக் ஆன் வாட் இஸ் யுவர் எக்ஸ்பீரியன்ஸ் டுடே அண்ட் வாட் யூ வாண்ட் டு டூ.
타이셀 공법으로 태풍 피해를 많이 막고 있습니다. 그런 저희가 30년간 연구와 설치를 한 결과 저희가 한 번도 파손되지 않고 파도를 잘 막고 있습니다. 이런 기술들을 인도에 잘 접목하면 해안가를 아주 관광지로도 바꿀 수 있고 태풍 피해를 많이 막을 수 있을 거라고 확신을 합니다. 그래서 SCS와 함께 이 큰 프로젝트를 수행하기를 바랍니다.
He is as a company that produces breakwater technology, namely Tiecell, in a country where it's attacked by a lot of typhoon, and in the last 30 years after thorough research and development, they have come up with this technology, and it has been working well in Korea. So he hopes that in future, along with HECS, they're able to create a better future for India as well in terms of coastal and shore care and other such disasters and prevention.
நாங்கள் போட்டிருக்கிற ஒரு MOU துவக்கத்துக்காக 10 வருஷம் போட்டிருக்கிறோம், 10 இயர்ஸ். இந்த 10 இயர்ஸில் வந்து எனக்கு தெரிஞ்சு எப்படியும் ஒரு 100க்கு மேலே ப்ராஜெக்ட் பண்ணிடலாம். இது வந்து ஒரு ஹையர் எண்ட், அதாவது அரசாங்கம் தான் மேக்ஸிமம் இது பண்ண முடியும். தனியார் வந்து ஒரு 25%, 75% அரசாங்க கையில் தான் இருக்கும். ஸோ இது வந்து லாங் டேர்மாக பண்ண முடியும். அதை உடனே இதை ஒரு சூவேஜ் பிளான்ட்டை போட்ட மாதிரி இல்லை ஒரு RO பிளான்ட்டை போட்ட மாதிரி பண்ண முடியாதுங்க. இப்போ ஒரு கோஸ்ட், இப்போ 800ல் 1 கிலோமீட்டருக்கு வேலை பார்க்கணும்னு வச்சுக்கிட்டிங்கன்னா, அதில் டேட்டாவை எடுத்து அதை கலெக்ட் பண்ணி இவங்களோட நாங்கள் கலந்து ஆலோசனை பண்ணி அதுக்கப்புறம் அவங்க அந்த டிசைனை ப்ரிப்பேர் பண்ணி அந்த டிசைனை வந்து நம்ம இந்தியாவில் வந்து IIT தான் அப்ரூவ் பண்ண முடியும், IIT மெட்ராஸ். அவங்களுடைய ஒப்பனையை வாங்கிட்டு அதுக்கப்புறமா அதை வந்து ப்ராஜெக்டாக நம்ம பண்ணணும்.
ஸோ ஒரு ப்ராஜெக்ட் வந்து 2 வருஷம் போகும் சார். ஆனால் இது எல்லாமே வந்து ஹையர் வேல்யூ. ஒரு ப்ராஜெக்ட் வந்து குறைஞ்சது பார்த்தீங்கன்னா 50-60 கோடி கீழே பண்ண முடியாதுன்னு நினைக்கிறேன். ஸோ அந்த அளவுக்கு இது பெரிய இது. இதனால என்ன ஆகும்னு கேட்டிங்கன்னா, இவங்களுக்கு இந்தியாவில் நாங்கள் வந்து அவங்களை அரவணைத்து அவர்களை வந்து சேர்ந்து ஒரு வியாபார ரீதியில் கொண்டு போக போகிறோம். ஸோ இதில் வந்து எந்த கவர்மெண்ட் அப்ரூவலோ எதுவும் தேவை இருக்காது. ஏன்னா எங்கள் பேரில் பண்ண போகிறோம், சேர்ந்து பண்ண போகிறோம். ஸோ இதில் வந்து நோ ஹோல்டிங் டைம், உடனடியாக நாங்கள் வேலையில் இறங்கலாம். அது ஒரு அட்வான்டேஜ். ஸோ எங்கள் கம்பெனி இவங்களும் சேர்ந்து பண்ணுறனால அரசாங்க உடைய இப்போ இவங்க போய் அப்ரூவல் வாங்க தேவையில்லை, நாங்களே அதை பண்ணி கொடுத்துட்டு வேலைகளை துவங்குறதுக்கு வாய்ப்பு இருக்குது. ஸோ அதி சீக்கிரமாக இதை வச்சு பண்ணுவோம் சார்.
일단 SECS와 지금 일단은 연구를 진행하고 있고 그 연구를 바탕으로 해서 한국의 기술들을 이전할 것이다. 이전해서 인도뿐만 아니고 아시아 지역, 예를 들어서 인도네시아, 필리핀, 베트남 등 여기 인력을 이용해서 해외로 진출을, 거기에 필요한 것은 여기 있는 SECS의 인력들을 교육시키고 그 다음에 기술 이전을 해서 잘 한 다음에 저희가 가지고 있는 특허 펜던트 70개국, 전 세계 70개국에 진출을 할 수 있도록 많이 돕고, 우리는 요 유능한 인재들, 그리고 적당한 인건비를 활용해서 전 세계 시장을 잡을 수도 있을 것이다. 그래서 협력을 10년 동안 진행할 것이다.
We've signed an MOU for the next 10 years, and the plan is such that using the technology that they have created, they will use it for India and along with HECS's help. And not just that, use this as a base to also spread along Asia as well, in Indonesia and Philippines as well, where they already have deals going on. And teach the HECS's employees and their way, so that it's not just them sending a prototype saying that you have to make it like this. Be hands-on with the project and create the project and grow together in the future.
There will be a lot of technical training and interaction such that we will also be able to solve the problem along with it.
Thank you, sir.
Thank you.